Hello and welcome to Physics Doctor. My name is Dr. Kanshyam Tejani and let's start. Class 11, chapter number 4, Motion in a Plane. And the similar content, it is from JEE NEET, unit number 2, Kinematics. And this is session number 9, part 2 of projectile motion. In the part number 1, we studied projectile motion. Especially, it was associated with inclined projectile and from ground to ground, that means a level ground. In this session, we will be focusing on projectile motion. Of course, it is horizontal projection as well as inclined projection. And also, in this case, also we will be deriving equation of trajectory and we will be taking large number of examples from NEET, JEE and JEE advanced question. So let's start. Let's just have a revision of projectile. See, projectile, that means an object, if it is thrown in air and it is having a two kinds of motion. One, it is having horizontal motion. It is having horizontal motion along x-axis and it is also having vertical motion along y-axis. So combination of these two motion it is having, and such a parabolic path it is covered by an object which is thrown on air and having two motion. One is along x-axis and second is along y-axis. So projectile motion has a vertical component and a horizontal component. Say for example, this object it is thrown at some angle. We call this majorly as a theta at some angle, and velocity of this object which is u. So it is having two component, one along the x direction, one along the x direction. We call as a ux, and ux is equal to u. Near angle we can take cos theta. We know that two component how to take. And on the opposite side, another angle that is for the vertical component, that is uy is equal to u sine theta. That we know very well. So the vertical component of the motion is subjected to gravitational retardation, while the horizontal component remains constant if air resistance is neglected. So if object it is thrown in the horizontal direction, it is having acceleration, but acceleration which is subjected to gravity, which is a is equal to minus g, and both are having perpendicular angle. Therefore, horizontal horizontal acceleration is 0, and because of that ux remained constant, whereas vertical uy it is subjected to gravity. That means object moves in the upward direction, then it reaches to top. So here velocity becomes 0, then it goes in the opposite direction, velocity become negative, and then here it is maximum. See, we already studied this concept in the chapter number 3. It is object subjected to gravitational acceleration. Let's consider horizontal component again. Here horizontal component, we know that it is known as ux, and ux is equal to u cos theta. Ux is equal to u cos theta. Whereas vertical component it is known as uy is equal to u sin theta. Then next is for horizontal component acceleration is 0. For horizontal component acceleration is 0. There is no acceleration. There is no acceleration along the horizontal. That means ax is 0, while vertical component is having gravitational acceleration which is negative, because gravity pulls towards earth center. So we know this thing. See, we are studying actually kinematics, and here law of motion are very much important, and you can solve all the examples of projectile by using law of motion. But some of the equation I think you should remember to save time, because during examination certain equation should not be derived to solve a simple example. So we know that equation of motion v is equal to u plus at, s is equal to ut plus 1 of at square, and v square minus u square is equal to 2as. We have three equation. Let's take first equation of motion. V is equal to u plus at, and if we consider horizontal and vertical component of this velocity, so we know that Vx, we can take Vx, Ux, Ax. T, it is a scalar component. It is a scalar quantity. Therefore, you cannot have x and y direction for time. So Vx, we know that Vx is equal to Ux. Ux, we already have Ux is equal to u cos theta, and there is no acceleration along x direction. So acceleration becomes 0. So equation becomes Vx is equal to u cos theta. Then we can take the first equation along the y direction to derive velocity along the y. So it becomes uy ay. So uy, we have uy value is equal to u sin theta, which is initial velocity, and acceleration a is equal to minus g. And therefore we have second equation, vy is equal to u sin theta minus g of t. Then we have second equation, s is equal to ut plus 1 of at square, which represent distance with respect to time. So again we can take the similar case here for the second equation of motion. So we can take horizontal distance x. So distance along x, we can take this distance along x axis. So as x, you can take ux ax. Again, acceleration along the x is not, therefore it is 0. So as x, that we can also write x, as x is equal to ut cos theta, or you can write equal to x also. That is also okay. The similar equation we can use for the vertical component, that is sy is equal to uy ay t square. What is uy? We have uy, value of uy, we have uy is equal to u sin theta, we can take here as a theta, and acceleration is equal to minus g that we have. So here sy is equal to ut sin theta minus 1 of gt square. Sy we can write, as a negative y. Negative y? It is not negative y, it is positive y. Right? So we got this. Then we have equation of motion for the third case also. We can see here this is third equation of motion. V square minus u square is equal to 2as, and which represent a relation with respect to distance. Relation with respect to distance. We can take Vx, Ux, Ay, acceleration becomes 0. Therefore, Vx square is equal to Ux square. We have similar equation here. Vx square is equal to u cos theta square. And we can take y also. We can take y component also. Vy square uy square is equal to 2 as. What is a? Acceleration become minus g. Uy, we have uy value of uy. We have value of uy. We can put value of uy here. So Vy square minus u sin theta square is equal to minus 2g sy. See, this we all know, but we have to repeat this again and again to memorize, or to just have a penetration this into our blood. And once you remember this, all the equations, or how to use this equation, your concept will be very strong. And whenever such examples are there, you will be able to solve such examples with very ease. So again, some of the terminologies, let's repeat the terminologies. So first is a velocity of projection, that u, right? So velocity with which the projectile is projected. Then angle of projection means at angle at which object is projected. Then trajectory means path taken by the object, right? So that is the trajectory. Then horizontal range, that means distance covered along x axis. Distance, or simply we can say displacement covered along x axis, that is known as range, or it is also known as horizontal range. Whereas time of flight, so time interval, so time taken to start the journey and to end the journey. Time taken to start the journey and to end the journey, that is known as time of flight. And you can see maximum height is also one term, which is a maximum height with respect to its horizontal axis, or you can say ground, taken by a projectile, that is height. So these are the different terminologies which is also required. See, during you can say uh, question solving, these terminologies are very much important. If you misunderstand the terminologies, you are going to go a wrong answer for sure. So now, the study of motion of the projectile, we did inclined projection on the ground level. So what we started here previously, we did this, the projection of the object, it is the ground. Let's consider this is ground. Object was given some velocity u, and then it moves and it falls on the ground, on the level ground, we can say. So we studied previously this session. In this session, we will be focusing majorly on horizontal projection. Horizontal projection, you can say on the ground, you cannot have horizontal projection. You need some height for horizontal projection. So let's say on a building, you are, say for example, you are on a building, on a terrace of a building, you are here, and you throw some object on the horizontal side, and how it projected. It may projected like that, and it falls in this condition, right? Do not imagine dirty things. It is not for that. Also, we will be taking some of the examples for the inclined projection. Then inclined projection on angle plane also will be taking. So let's go with horizontal projection. You can see here the drawing which is having some height h, and from the height h, a person is throwing something, a ball. Let us just assume a ball. A person is throwing a ball with velocity u along the horizontal direction only, right? That person is throwing an object along the horizontal only, and because of that, it moves along this side, and it covers some range, it covers some height. Fine. So here, projectile from height to ground we are considering, and we know that horizontal component and vertical component. Let's take horizontal component. This object is having u, and we can say it is having two component. It is having one component ux is equal to u cos theta. What is angle with horizontal plane? What is angle with horizontal plane? It's 0. So cos theta, that means cos 0 is 1. So see here, ux horizontal velocity is equal to actually initial velocity. Horizontal velocity is equal to initial velocity, and we can also take vertical velocity u y is equal to u sine theta. What is theta? Theta is equal to 0. That means sine is equal to 0. Sine theta, sine 0 is equal to 0. Sine 0 is 0. That means uy is equal to 0. That means there is no vertical movement. There is no vertical movement. Then what about acceleration? The terms are similar. Vertical acceleration, see object is moving in the direction ux, whatever. But see, there is no vertical. There is vertical acceleration definitely, but vertical acceleration is not providing any benefit to horizontal movement, or there is no loss for the horizontal movement. That means horizontal movement is constant, and there is no horizontal acceleration. That means ux, it remain constant. Horizontal movement is not changing with time. Means motion. Whereas vertical object, yes, vertical movement, object is subjected to gravitational load. It is not load, it is acceleration. Therefore, a vertical ay is equal to minus g. Then we have equation of motion, three equation of motion. Let's take the first one. This is the first one. V is equal to u plus at. We can take vx is equal to ux. Along the x direction, a is equal to 0. Along the x direction, a is 0. Ux is equal to u cos theta is equal to u. Therefore, vx is equal to u. Vx u is equal to u. After some time, velocity is x. That means along the horizontal component, velocity is not changing. Let's check for the y. Uy, a become minus g, a become minus g. Velocity along the y is equal to uy is equal to sine theta, uy is equal to sine theta. What is sine theta? Sine theta is 0. Therefore, uy become gt. Uy become gt, right? Object maybe after some time it is here. It is having some distance, say for example y, but this y become negative y. So, you can take is equal to negative y also. So, y is equal to gt. You can write in this manner also. So, for the first, we got our equation. Then next, distance. This is the equation of motion, that is for the second. Distance, it is showing s is equal to ut plus 1 half at square. We can take x distance along x. What is ux? Ux is equal to u. What is acceleration? 0 along. That means sx is equal to ut. Sx is equal to ut. So you can write here also, you can write x also. Not in the previous case, it was error. And here sy is equal to ut sine theta minus 1 of gt square for the vertical component. Sine theta is 0. So therefore sy is equal to minus 1 of gt square. You can write here minus y for this case, not for the previous one, not here. But in this previous one, it was error. So we can write r means range. You can write r means total range. If it is taking total time, r is equal to, or you can take here x directional movement. Negative height, because we are taking here reference from the top position, from the initial position, therefore height is negative. So minus h, that you can cancel it out. Then we have equation number third. We can take horizontal and vertical movement, not together, not together. So for the horizontal, ax becomes 0. So vx square is equal to u cos theta and is equal to u. And similar here, vx is equal to u, vy square is equal to 2gh. By using this equation, we can solve any of the example, but we may derive some of the example if you want to remember direct equations. You may go for that, but I do not suggest that for especially this topic. So let's go to equation of trajectory first. Projectile from height to ground. Horizontal component we have, right? We have equation of motion. We have sx is equal to ut cos theta. Say for example, after some time, object it is here at some point, and having distance. This distance is x, and this, from the distance from the vertical, we can take as a y. So negative y, because we are taking reference as this point. A point is our reference, therefore negative will be cancelled. So one equation is x is equal to ut. Second equation is equal to y is equal to 1 of gt square. Can we take t is equal to x by u? Can we write t is equal to x by u? Yes, of course. And y is equal to 1 by gt square. Can we take, can we add value of t, in the equation number 2? Of course we can. So y is equal to 1 of gx by u square, and you can rewrite this equation. Y is equal to g divided by 2 u square x square. So this is equation of trajectory when object is thrown at some height. So you remember this equation. I think you should remember this equation, or you may directly work out on equation number 1 and 2, and you may also derive at a time of examination. Whatever you wish, you can go for it. You can remember this equation, there is no issue. Then let's have example. Example number 1, a pilot flying his bomber at a height of 2000 meter with a uniform horizontal velocity of 600 kilometer per hour wants to strike a target. At what distance from the target he should release a bomb? So Let's do a plan. This is our plan, excellent plan. We can see fighter plan. You assume this is our fighter plan, and here pilot is sitting inside the cabinet and he wants to throw a ball. He having some velocity. He having some velocity, and he wants to throw a bomb and somewhere here target. So he starts from the A position. His height is 2000 meter, 2000 meter, and and here target is B. So here target is B. So what is mentioned here? A pilot flying his bomber at height 2000 meter with a uniform horizontal velocity, that means ux, or you can write u also fine. We know that ux and u both are similar, so we can write here u is equal to 600 kilometer per hour. Wants to strike a target. So you know that the object is going to have a projectile because it is having combination of horizontal motion as well as vertical movement because of gravity. So here we know that h from the ground, h height from the ground is equal to 2000 meter, and u cos theta, or you can write, you can just remove cos theta also. U is equal to 600 kilometer per hour because theta is 0, because theta is 0. Then what next? We have equations from that. First, before that, here it is given kilometer per hour. We may convert this into meter per second. So kilometer is equal to 1000. So multiply by 1000, and hour you can say is equal to 60 minutes multiply by 60 seconds. So it become 3600 second, right? So it is in denominator. So divide this into 3600. So we will have a solution for that. Then what? Then what? See, we have three equations. We need here distance, we need here distance. So we have equation. You may remember these equations also afterward, but I do not suggest you to remember this equation because there will be large number of equation and you may get confused with the equation. So we know that S is equal to U T plus 1 of A T square. You can take here as x for the horizontal movement, as x for the horizontal movement, as x is equal to ux is equal to at. A is 0 because in the horizontal A there is no A. And what about ux? So ux is equal to u cos theta t. But here theta is equal to 0, theta is 0. So cos is 1, therefore ut. So simply you can write Sx means horizontal distance is equal to ut. And similar here for the Sy, vertical distance Sy is equal to uy is equal to u sine theta, that means initial velocity is 0, that means this system is 0. What about e? It become minus g, it become minus g. So our equation of motion, there are two equation of motion. R is equal to r is equal to ut, and h is equal to 1 of gt square, because see h is negative, therefore h is negative, therefore that will be cancelled out. So now what? Now what? We have two equations. Put the values here. R is equal to ut. R is given 2000 meter equal to 1 by 2 10 t square. Can we solve this? 10 1 10 is cancelled, and you can say is equal to 400, and under root 400 is equal to 20 seconds. So it, see, bomb will take 20 seconds from the release to reach its destination, and while that it is having projectile movement. So we got time first. See, in this kind of examples, you will always get first time and then you will have range. So from the first equation, you will get time, and from the second equation, you will have range for that. You may remember equation for range directly also if you wish, but I do not suggest to remember large number of equation. It may add confusion for that. Then second equation, we have h is equal to 1 of gt square, and r is equal to ut, that also we have, right? We put in the first equation and then r is equal to ut. So r is equal to 600 multiply by 1000, you can just cancel out this and so r is equal to 3333 meter. R is equal to 3333 meter. So we will have either equation number 1, this is one number, this is two number, whatever equation you want to go for that, you may go and solve the example. So bomb should be released at 3333 meter from the target. So R is 3333 meter. Example number 2, a ball thrown horizontally with a velocity 5 meter per second from the top of the building. So see here, there is a building we can see on the drawing. There is a building, and from the building ball is thrown horizontally with initial velocity u is equal to 5 meter per second. And from the top of the building of height 80 meters, so here this is given h, and here initially this is given u velocity. Take g is equal to 10 meter per second square and find first the time taken by the ball to hit the ground. So see here, object is subjected to two velocity. One is horizontal, another is vertical, and because of that, that object moves. Keep on taking this profile, and it hit a point B. It hits a point number B. And during this journey, time taken we need to identify. Time taken for this journey we need to identify. Second is the distance from the base. See, this is the building base. This is the building base. Distance from the base of the building of the point where ball hits. Ball hits here at point B. So we need this distance. We need this distance. We can call it R, or we may call it X. If you want to call it X, you can whatever you wish. And the third, the magnitude and direction of the velocity of ball at t is equal to 2 seconds. Say for example, after 2 second ball arrive at this position, or maybe at this position. So what is velocity? What is velocity after 2 seconds? So we need ux and uy, maybe or may not, and also we need to have angle. We need to find out angle for this term. We can get this alpha for that case. So here h is given 80 meter, ux is given 5 meter per second. Then we have equations. S is equal to ut cos theta, s is equal to ut plus 1 half at square. That equation we already derived this. If we run along the x direction, so it gives ux cos theta, and cos theta is 0, so cos 0 is equal to 1. So sx is equal to ut. And similar here, sy is equal to ut sin theta, sin 0 is equal to 0. So this term is cancelled. And our answer r is equal to ut, and h is equal to 1 half gt square. We know this very well. Now what next? See, h is given. Yes. T is not given. G is none. So what should we do? Put the value here. H is equal to 80. G is equal to 10. You can have 0, cancel out. 8 multiplied by 2, that is 16. Root 16 is equal to 4. This is not 18, this is 16. So we got time. Ball is projected from this position, and when it hit to the bottom, if you throw from your terrace something, and it takes time, so you can calculate the time required for that part. So here time it is taking 4 seconds, right? So see, in the 4 second where ball arrived at point number B, and now that means what, it covers horizontal distance this much. So we have r is equal to ut. Now put the value of time, initial velocity we have 5 multiplied by t is equal to 20 meter. That means from the building 20 meter distance it is available. That means ball will hit building away from the 20. Wow. Then next is the magnitude and direction of velocities. Now we need velocities Vx and Ux, not Ux, Vy. Do we have equation for that? Do we have equation for that? V is equal to u plus at. We have equation. We already seen this equation, so we can write Vx is equal to ux is equal to x. Along the x direction, acceleration is a 0, so this term is not required. So Vx is equal to ux is equal to u cos theta, and theta is equal to 1, so Vx is equal to u. So Vx is equal to u. U is not changing along the x direction, so no calculation is required. But what about y? Vertical movement. What about vertical movement? Uy is equal to Vy is equal to Uy is equal to acceleration. Now for the vertical component, acceleration is equal to minus g. So put minus g here, and Uy becomes sine theta. Sine theta is equal to 0 because angle is 0. So this term is not there. Therefore, Vy is equal to minus gt. Vy is equal to minus gt. Now what? Uy is equal to u is equal to 5, and Vy equal to minus g is 10. T is equal to 2 is equal to minus 20. See, minus, it is just showing direction. It is just showing direction. If you take direction directly in the downward direction, so Uy become 20. Now what next? If you wanted to have magnitude, so we know that mode V is equal to 5 square plus 20 square, so equal to 20.6 meter per second. You may calculate that also. And we know we want a direction. Now what we want? We want a direction. So for the direction, we know, right, equation, we have tan alpha. If we want had to have this equation, tan alpha, not with this but with x, with ux, so it is tan alpha, not this one, tan alpha with x direction, so equal to uy, or you can say vy divided by vx, vertical component divided by horizontal component. So answer is equal to 4. That means alpha is equal to tan inverse 4. We have one more example. Example number 3. I think you should pause the video and solve this example. You can. So body is projected horizontally from the top of the building. It is very similar case. It strike the ground after a time t. We know that with its velocity vector making an angle theta with horizontal. So this angle with velocity vector makes an angle theta with horizontal, right? So the speed with which the body is projected is, okay. So we have equation, that means the speed, initial speed, talking about the speed at which body is projected, that means u. So u is equal to gt sine theta, gt by cos theta, gt by tan theta, or gt by cot theta. You will have this kind of questions in the examination. So let's start our initial method. You can have s is equal to ut plus 1 half gt square. You can take x component and y component. We already did this, so not repeating again. So we know that x, or you can say r, is equal to ut, h is equal to 1 half gt square, and vx is equal to u, vy is equal to minus gt. For the velocity, v is equal to u plus at. We already derived this equation. Here we need velocity. That's why equation we need velocity equation. And also we know that tan alpha is equal to vy by vx. Tan alpha is equal to vy by vx. If it is making angle with ground, so opposite angle, we know that opposite angle we can find it out easily. If this angle, not this one, alpha, then horizontal angle with horizontal, we know that z, this angle, both will be equal. So tan alpha is equal to vy by vx, and can we put this gt by u, considering this vertical line, so negative minus gt is not required to write, only we can write positive because we are just finding angle within this region. So u is equal to gt by tan theta. Do we have solution? Gt by tan theta. Yes. So we did not require the above equation. We just need this equation to solve this example. Oh, we have one more example here. Example number 4. A person wants to jump over a ditch as shown in figure. So here is a person wants to jump and find the minimum velocity with which he should jump. So we need to have, we can write here initial velocity u, and this range person has to jump 3 meter along the x direction and 2 meter along the y direction. So r is equal to 3, h is equal to 2, and vx we need to find out with what velocity person should jump. So that we have equation s is equal to ut, s is equal to ut plus s is equal to ut plus 1 half gt square, or not gta, we can write at square. And from that we derive two equation, r is equal to ut, h is equal to 1 half gt square. I am repeating this equation again and again because you will remember this equation and it should penetrate in your blood. So r is given 3 and h is given 2. So h is equal to 1 half gt square. You may put these values and you can find t is equal to 0.63 second. Do this calculation and you will have solution for that. Now what next? We have one more equation. R is equal to ut cos theta. So cos theta is not required even. Cos theta is 1. So u, and u is equal to 4.73 meter per second. So person has to jump with initial velocity 4.73 meter per second to ditch this ditch. We have one more example. A pressure tank issue water at A. So that means some release point is given. This is a pressure point. This is a pressure tank. And here there is some release is given. Water is coming out with initial velocity. Let's assume u. Let's assume u with a horizontal velocity u. For what range the value of u will water enter the opening BC? See here there is some wall opposite side, and you can see the distance from the water tank, or you can say from this opening is given, that is 1 meter. So here there is some separate passage is given. So the passage start from below 1 meter and it ends 1.5 meter. That means within this region we have to flow this water. So water is having projectile motion, and he can take here 3, that become range, and here 1 become h1, and 1.5 plus 1, that means this total length become h2. So now equation is very simple. So r is equal to 3 meter, h1 is equal to 2 meter, not 2 meter, it is 1 meter. So h1 is equal to 1 meter to 2.5 meter, and what is ux? Range we need to find out. So we know that equation as x is equal to ut cos theta, and we already derived this equation so many times. But you remember this equation, right? You always repeat this step during calculation also. I strongly suggest you do this. R is equal to ut, h is equal to 1 half gt square. We can find h1 for the first height. H1 is equal to 1 half gt1 square. So time required for the first movement for the top one, when the object passes only from this point, is this water passes through this point, top point, that is h1 height. So we can find h1 is equal to 1 meter is equal to 1 by 2 10 t square, means t1 square. Let's put t1 here. So t1 is equal to 0.45 second. It will be taking 45 second. We have one more equation, r is equal to u1 t1. Put here time t1, put here time t1, and u1, value of u1 that we already have for the initial velocity. We don't have initial velocity, we have only r. So r is equal to 3. So put r here, and u1 is equal to 6.61 meter per second, right? So pressure should be 6.61 second for the first case. So this will just passes through this region. What next? Repeat the process for H2 position. H2 is equal to 1 by 2 GT square. Put the value of H2, that is 2.5. Now this H2 is required from the total height, and now water should flow like that. Water is flowing. This is, assume that this is a parabolic curve. So here 2.5, H2 is equal to 2.5, G is 10. You can put value, you can find T2 is equal to 0.71 second, right? So water is taking to 0.71 second from position to start to end to reach point C. Then we have R is equal to U to T2, and then put the values of R3, U2 is equal to 4.2 meter per second. So range, we got the range initial. If you want to have in between the range of 6.61 meter per second or 4.2 meter per second, if you arrange this tank in a such a way that so it always passes through this region. Example number 6. I think you should pause the video and you should solve this example because similar example we have solved previously also. See, if you do not solve unsolved example, this never going to bring a confidence. Just watching this video, you are not going to learn it. You have to practice it. And how? You unsolve each of the examples which I am showing here, and then you should match your method, your steps with this. There can be a different method. See, you can solve this all the examples by using 2 3 different methods, and which one suits better to you, you may get it for you. So here it is given a building P is 150-meter tall. A building height is given. This is H. Is at a distance of 100 meter from another building. So see, this is building 1, P building. Building number 2, it is Q, and the distance between two building is 100 meter. A ball is thrown horizontally from the top of the building. See here, you are throwing a ball. Imagine that you are throwing a ball, right? In such that it enters a window. Some person, Chandu Bhai brother is here, and you want to enter some parcel here. At Q, at height, it is given from the bottom 25 meter, right? The speed in meter per second with which the ball is thrown must be take G is equal to 10 meter per second, and the ball should be having 20, 30, 40, or 50 meter per second speed. So here do you need to throw the ball. See, now your problem it is like that. This is, you can take this as a reference, and your height, it should be height. It should be, you can take H prime height. It should be 150 minus 25, so it become 125. Now it is solved. The problem is solved. Very similar. As x is equal to 3, y is equal to 125. We have two equations. Sx is equal to ut cos theta. We have r is equal to ut, that become r 100, and h is equal to 1 half gt square. Do we have value of h? Yes, 125. Now it is not 150. Do not make mistake. Our relative height is only 125. Put the value h 125, and then you will have your solution t is equal to 5 seconds. And what next? We have r is equal to ut range. Put the value of r is equal to ut, and therefore answer u is equal to 20 meter per second. You have to throw this ball horizontally at 20 meter per second, so it enters a Chandubai's window. Wow, what a question! The question is very simple, but you need to understand the exact logic, basics of the subject. Here we have example number 7. A rocket is released from a jet fighter horizontally. Let's do, say for example, here it is a rocket is released. Oh, rocket is released from a jet fighter flying horizontally at initial velocity. Let's take u is equal to 1200 kilometer per hour. If it is given in kilometer per hour, we need to convert this into meter per second. Let's wait. So at an altitude, that means it is given height, altitude, that is it is given height is equal to 3,000 meter above its target. The rocket thrust gives it a constant horizontal acceleration. That means rocket is burning, and here problem changes. That means it supplies some acceleration continuously. Acceleration is supplying here, so horizontal ax, it is not zero, it is having some value, and it is in 6 meter per second square. If you simply remember the equations and you derive the solutions, definitely you will have a wrong answer, and your answer definitely will be there in the options. So simple, you just remember equation. This is never going to work. Always work with the concepts. So here Vx is given, or you can say Ux, or you can say Ux, or U is equal to 1200 kilometer per hour is given. Height is given 3000 meter, and Ax is given 6 meter per second scan, and also we can say Ay is equal to minus G. That we know it very well. Wow. So we have to first convert this Vx into meter per second. So we have kilometer. 1 kilometer is equal to 1000 meter divided by hours are given. So 1 hour is equal to 60 second multiplied by 60 minutes. So become 3600, right? So kilometer per hour become meter per second. So this is conversion. You should know it. You should not make mistake here. Then what next? See, next is we have so many equations. Let's change the color. Equation of motion, we have S is equal to ut plus 1 half at square. If we take direction along the x axis, so that become sx, and here become ux and ax. So ux, we know that ux is equal to u cos theta, and therefore become u. T is t plus, see here ax is not 0, so that means equation it remain like that. Sx is equal to ut plus 1 half at square. That equation we have. S is equal to ut cos theta is 1. So ut plus 1 half at square, right? So it is like that. You may remove this, fine. Similar here, you can derive equation for y. Ut u sin theta, so this becomes 0. Sy is equal to 0 plus 1 by gt square. So Sy is equal to, this term becomes 0, and however your equation is r, you can take a range or you can take x is equal to ut plus 1 half ax t square, right? You cannot remove here because x it is given here, ax is given, and h is equal to 1 half gt square. So in the second equation there is no change. Let's put here h is equal to 3000, h is equal to 3000, and t is equal to 24.5 second. We got t is equal to 24.5 second. Now what next? We have equation of r. So here Sx is equal to ut plus 1 half ax t square, that you have to remember. Yes, put the values here, put the values here. R is equal to 1200 multiplied by 1000. You can simply calculate this. T is given 124.5. Cos is not required. 1 by 2, and R is equal to 10,000 meter. 10,000 meter. And here angle, we know that angle is equal to tan theta. You can take any y component divided by similar x component. So tan theta is equal to sy by sx is equal to h by r. 3000. You can remove this 3 by 10, and theta is equal to 16.5 degree. Here example number 8. Two bodies are projected horizontally in the opposite direction. So say for example, a body A is projected in the right hand direction with, and another body it is projected on the left hand direction with u1 and ut velocities from the top of the building. If their velocities become perpendicular to each other, oh, good. So if this there is a projection, it is like that, and velocity continuously changes its movement. So if here at certain level, if this is the velocity, this is the velocity. If we extend this after some time, we can write v2. If we expand this line, and here at certain position, if we extend this line and this become 90-degree, oh, perpendicular to each other, wow, that we already studied this kind of concepts during vector. Let's see. So perpendicular to each other after falling through a distance h, after falling through some distance h, that means at this h distance, it is having this kind of velocity. Oh wow. So initial velocity ux is equal to u cos theta is equal to u uy sin theta, that we know is equal to 0. So initial velocities for the first u1 component, for the u1, so u1 is equal to u1I plus 0j. We can write in the term of vector because here we need to have measure the perpendicularity. So initial vector u1 is equal to u1I plus j, and vector after some time. So when this object reaches at height h, what is the vector of u1? So we can write vx is equal to u1, vy is equal to minus gt, because v is equal to u plus at. When there is a ux ax, acceleration is 0. That means vx is equal to ux, and ux is equal to u1 for the first component, that means u. And similar here, vy is equal to uy plus ayt. So here uy becomes 0 because sin theta is 0 minus gt. So after some time, vx is equal to u1, vy is equal to minus gt1. So therefore, vector v1 is equal to u1I minus gt j. I and j, I represent x direction, I represent x direction, and it is unit vector along x. J represent y direction, which is unit vector along y direction. Similarly, can we derive? Similarly, can we derive? Let's. Oh, oh, oh. Similarly, can we derive? Similarly, can we derive for the body object which is thrown on the opposite direction? Object thrown in the opposite direction is having some velocity v2. Can we derive for that? Can we derive for that? Yes, it will be similar only. You can have u2. See here, we can consider this direction is a positive. This side we can consider as a positive. So opposite side should be negative. Opposite side should be negative. Therefore, here u2 in the opposite direction become negative, and in the similar direction it become positive. So it become v2 is equal to minus u2I minus g, because downward direction is the same. Downward movement is the similar for both the cases. So there is no change in the downward direction. We have two vectors. We have two vectors. One vector, it is in the direction. This is v2 vector, and another vector, it is having v1, and both are having 90-degree angle. Both are having 90-degree angle. So what is the case? See, we studied during vector, right? We studied during a vector, and we studied two components. One is dot product and another is cross product. If you are missing with vector, if you not understand the vector, I think you should search on YouTube physics a doctor vector a math tool, where we stated conditions for vectors. So see, there are two possibilities. One is vector dot product, another is cross product. And let t assume that after some time t, when it reaches to height h, after some time t, V1 and V2 become perpendicular to each other, and at that time we know that vector, we need to study orthogonal property of vector. In the math tool, we studied that orthogonal property, that means when angle theta is 90 degree, dot product of vector A dot B is 0. A dot B is 0, theta is equal to 90 degree. That means cos theta is 90 and it is 0. That dot product, it is having this kind of formula. And how to do dot product? Suppose if we wanted to have A dot B, suppose A is equal to A1I plus A2J, and B is equal to B1I plus B2J. So dot product A dot B is equal to multiplication of A1 with B1 I to I, multiplication with A2 B2. So that is dot product. Let's apply here. So we have V dot V1 dot V2 dot is should be 0, because dot product orthogonal property is 0 here. So U1 is equal to U1I minus GTJ, U2I minus GTA. What is U1 minus U2? So it give minus U1 U2, minus minus become plus, so GT square. Therefore T is equal to 1 by 2 U1 U2. We got equation number 1. We need here solution for what? H. So we have Sy is equal to Ut sine theta minus 1 by 2 GT square, that we already know this equation. Sy get gives minus H. Put the values here. Sine theta is 0, so this value is 0. H is equal to 1 by 2 GT square. See, you can write direct this equation also, but to understand, for your understanding, I am just repeating this part. Put value of T. So H is equal to U1. Put value of T, that become 1 by 2 G. What is T? So it become 1 by G under root U1 U2, and that is a square. So H is equal to U1 U2 by 2G. This is the solution. Where is that? H is equal to U1 U2 by 2G. So we have here D is our solution. We have here example number 9. A body is projected horizontally with a velocity U meter per second, that we know from height H. We are solving this kind of example. First, state initial velocity in vector form. It is mentioned here. Second, find velocity vector and direction of motion after a given time, means after t time, maybe at this position object reaches here after t time. And third, find the coordinates, means distance, range to height, or you can say x to y distance, coordinates. And fourth is velocity and direction of motion at given height. So with compared to height, this is required. Let's find it. We have all the equations with us. So first is initial velocity. We know that this we write ux is equal to u cos theta, uy is equal to u sin theta. Therefore u bar is equal to u cos theta I plus u sin theta j. Cos theta is cos 0 is equal to 1. That means u bar initial vector is equal to u of I plus 0 of j. Oh, good. Second is velocity after t time, after time t. So we have v is equal to u plus at. For x, at becomes 0. So vx is equal to u cos theta and is equal to u even. Simply. Similar, vy is equal to u sin theta minus gt. Here you can put minus vy is equal to uy plus a become g. So that become minus gt. Ui become u sin theta. So this cancel is 0. This term is 0. So what is vector? U v bar is equal to ui minus gtj. Oh, vector. We got vector. Great job. If you wanted to have angle, so we know that tan theta is equal to Vy, vertical component divided by horizontal component. So tan theta is equal to minus Gt by U. If you just consider direction as downward direction. So minus sign is not required for that. Case number 3, what we need, find the coordinates. That means we need distance. So we need equation is equal to s is equal to ut plus 1 half at square. For the sx, only ut will be there. This term is 0, and for the vertical term, the first term is 0, second term is there. So sx is equal to ut, sx is equal to ut, sy is equal to minus 1 half gt square. So s bar is equal to uti, that is plus, you can take minus 1 half gt square of j. And the last one is that velocity. We know that v square is equal to v square minus u square is equal to 2as. From that, you can find out this equation. Acceleration for horizontal component is 0. So v x square is equal to u square. For the vertical component, v y square minus u sin theta 2gh, and therefore v, see h is negative, therefore negative h, negative g become positive, both become positive. So v square y is equal to 2gh. And if you want magnitude, we can take Vx plus Vy, so u square plus 2gh. If you remember, in the case of the full projectile from ground to ground, this equation u square, that was minus 2gh, but here it is plus 2gh. There is a difference. And the direction tan theta is equal to V by Vx. So comment your answer. Comment your answer. You do some activity here. Otherwise, it won't work for you. Here, example number 10, a body is projected horizontally with a velocity 5 meter per second from height 20 meters. So here we can draw an object, a body, which is thrown horizontally 5 meter per second, u is equal to, and at height it is given 20 meter. So body is projected like that, it will project like that and touches the ground. So first we need to find state initial and final velocities in the vector form. Second, find the velocity vector speed and its angle with hp after 2 seconds, and find the displacement vector. Right, so I think you should pause the video and you can solve by yourself. Example number 10. Solution, let's find. U is given 5, this is u is given, and height is given 20. So we know that ux is equal to u cos theta, uy is equal to u sin theta. We solved this so many times, so we can take vector if you want to take vector. So vector is equal to u cos theta. Cos theta is 1, sin theta is 0. So is equal to 5i plus 0j. You compare results, your solution with this. We already solved in example number 9. The similar concept was addressed. And the final velocity, Vx is equal to u cos theta in the horizontal direction, that is not going to be changed. Vy is equal to u sin theta, so that becomes just 0. So g is given 10, so we can take g is equal to minus 10. So final vector after t time also you may consider like that. So now velocity after t time equation is same. We put here v is equal to u cos theta, so it just become u. This cancelled, right? So u is equal to 5, g is equal to minus 10. You can put t is equal to 2 seconds, so you will have your solution. Comment your solution. Comment your solution. Comment your solution. Your value of v, and angle also. Comment your angle. And the last is displacement sx is equal to ut, sy is equal to minus 1 half gt square. That you need to solve. Uti minus 1 half gt square of j. This is vector, and give me displacement of the same. Give me displacement for the similar case. So here example number 11. A body is projected horizontally from a point above the ground. The motion of the body is described by the equation. Oh, equation is given x is equal to 2t, y is equal to 5t square, where x and y are horizontal and vertical displacement. So see, you can have examples in this manner also. Equations are given. The trajectory of body is, is it coming? A straight line, a circle, an ellipse or parabola. See, you can say this answer is parabola. You may directly say, but see, you are studying this chapter parabola projectile. That's why you can say. But see, when you will be having the entire course at that time, you may not be able to identify that the question is from the projectile or some different topic. So always go with equation. Equation is given x is equal to 2t and y t square. So what you should derive? You should derive relation between x and y. So what we can do? We can t is equal to x by 2. We can put t is equal to x by 2. Put the value of t in the equation of y. So y is equal to 5x square. That means see y proportion to x square. Have you remembered this term? Have you remembered this term? X proportion to y proportion to x or x proportion to y square. That means it gives a parabolic curve. It gives a parabolic curve. So the answer is the correct answer. Answer is parabolic curve. Example number 12 we have what is the velocity with which the body in the above question. So we need here velocity. We need here velocity. X is given, equation is given, y is given. See, from the x equation we can find ux. X is equal to ut, ux, u cos theta, uy, u sin theta. That we know it very well. So see here we compare this equation x is equal to 2t. So we know that x is equal to ut. U is 2. U is 2. Similar compare. Similar compare. Y equation is not required even. You can directly go with this. Then question number 13, example number 13. What is the magnitude of velocity of the above of the body in above question after 0.2 second? So if you wanted to find velocity, we have x is equal to 2t, y is equal to 5t square, and we know that differentiation is required. So we can take vy or vx along x direction, dx by dt. We can have differentiation, so it become 2. And we need differentiation along y. So vy is equal to dy by dt is equal to 10t. So what is a magnitude? V is equal to 4 square, 10t square. You can put t is equal to zero point 0.2 and give me the answer for that. V is equal to 2 root 2. You will be having in NEET and JEE. You can have read 2 or option will be there also in the similar manner, right? So you can have one of the question or maybe multiple question in the examination. But we ready with this. We are covering all possible questions here. Example number 14. Oh, it is from JEE 2004 and we have been waiting for this kind of JEE questions. A ball is thrown from a point with a speed u at angle theta to the horizontal. Oh, from the same point and at the same instant, a person starts running. Oh, wow. A ball is like that. A ball is thrown from a point with a speed u at an angle theta to the horizontal. That means a ball is thrown, and from the same point at the same instant, a person starts running with a constant speed. So, person start with a constant speed u is equal to person speed. It is up. Let's write person speed up is equal to u by 2 to catch the ball. So, ball it is coming and a person is running in this side. So, here the ball, whatever movement of the ball and the person both should reach at the same side. Oh, wow. So, will he be able to catch the ball? If yes, what should be the value of theta? If answer is yes, 60 degree, 30 degree, or no, or yes, 45 degrees. So, you may try this by throwing a ball, you run and you may catch. You must have done this kind of exercise so many times. So this is the question where we can find out t is equal to 2u sine theta by g, r is equal to u square sine 2 theta by g, and h is equal to u square sine square theta. See, this is the question is not from the previous, but it was projected with some angle u, and this was theta. So person will catch the ball if a range ball starts from there and this reaches, this is the range of ball, and the person cover the distance if both are equal. So ball is thrown here, ball travels to this, and a person, it starts from this position UP, and if he covers the equal distance, in this case he can able to catch the ball. So here the person moves with the constant velocity, it is given ut, and the range, equation of range, we have r is equal to u square sine 2 theta. If both equal, right? If both become equal. So u by 2, we know that u by 2, that is person's velocity. V is equal to distance travel. So distance cover, it is x by a person. U by 2 is equal to x by 2. So t is equal to 2x by u. And what person has to travel? A person has to travel total r. So t time taken by the person to reach from this position, point number A, to B, person by person, that time taken by the person must be equal to time of flight. It must be equal to time of flight. So we identified here time for the person velocity, say for example v. So we know that distance travel is x, or you can say r, x by t. Therefore t is equal to x by t. But the, see, initial, the speed is given, person speed is given, person speed is given. Here it is not like that. T is equal to x by v. Person speed is given, it is equal to u by 2. That means it become 2x by u. Person speed is given half of the speed of the ball. So here we already have, now we have all the equations. Put the t time and put the r here. We can just have g, you may cancel out g, you may cancel out u square, 2 may be cancel out. Sine theta is equal to 2 sine theta, and 2 sine theta is equal to 2 sine 2 theta is equal to 2 sine theta. Cos theta sine is cancelled, that means cos theta is equal to 1 by 2. And what is your answer? What is your answer? Tell me your answer. 60 degree. Yes, answer is yes. Of course, you can throw a ball. You can throw a ball. You can catch. If the speed of the this ball is u, and if you run, your speed is u by 2. So you can catch this ball if you throw this ball at 60-degree angle. You can catch this ball at 60-degree angle. You can say that I can catch at any angle. It is not possible if your speed is half of the ball speed. Condition is given here. That's why this become complex. Oh, we have one more question. It is even difficult. Example number 15. A body is dropped from H. See, it is a vertical movement. So body is dropped from H above the ground. So total height, it is given above the ground. H is given, and it strike on inclined plane. Oh, there is an inclined plane is given. Inclined plane is given at a height small h above the ground. As a result, the impact of velocity of the body become horizontal. Oh, after that, this moves in the horizontal direction. Wow. And ultimately, it has to travel in this because vertical component is already there. So initial movement, it is vertical. See here, object starts from the top position. That means initial velocity is u is equal to 0. So let's just solve the first condition. So it is a condition where we studied when body objects having a free fall. Starting from top position, it is starting from the tower. It is dropping. Ball is dropping from the top to bottom. So we have equation of motion. This is equation motion 1, this is 2, this is 2, 3. So for the vertical distance, it is traveling. So what is distance travel? Distance travel is h minus h, capital H minus small h, that is distance travel. What is initial velocity? Initial velocity of ball u is 0, s is equal to h minus h, and acceleration is gravity. It is subjected to gravity, so minus g. So h minus h, 0, is equal to 1 of gt square. See, we know that when we are considering only motion in the one direction, right, towards the gravity, so distance is negative, and therefore velocity or acceleration is not required to take negative. You can take positive g for that case. If there is a motion, is a, it gets having a two-dimension motion. going up and moving down. So in this case, you need to take minus g, otherwise you can take directly positive g. Or else you can take this height as a negative, this height as a negative. Whatever you wish, whatever you want to go, you can try. So we have this h minus h is equal to 0, 1 by 2 gt square. So this is time required for this duration, time required for this we can call as a t1. This we can call as a t1. Fine. So here it is, we need to find the body will take maximum time to reach the ground for this condition. So we need time for both the cases. So we got time for first case t1 is equal to under root 2 h minus capital H minus small h by g. Now the body, the object, it strikes here and it moves initially in this direction. Initially in this direction. So h is equal to horizontal movement. We need horizontal movement. So h is equal to, see, s is equal to u t plus 1 half a t square. We can take horizontal movement, horizontal movement, horizontal movement. What about horizontal movement? Here it is, here it is, here it is. Some movement we don't know, some movement we know. What about acceleration? That becomes 0. But what about vertical movement? We can take y, you can take y. Sy is equal to u y t plus 1 half a y square. When we talk about vertical movement, so here it is 0. Here this value becomes 0. Sy become h opposite 1 by 2 g t square. You can take minus minus. You can remove this minus. So h is equal to 1 by 1 half g t square. So we got time from this condition also. T2 is equal to under root 2h by g. So from the time an inclined plane on the ground, this will be time for this T2. Body moves from this position and reaches at this position, and this is time for the first case. So total time is equal to T1. You can take here T1, T2, that is here. So now we got T1 and T2, but what is our question? The body will take maximum time. So for the maximum time, you need to have differentiation, because we know that we find the differentiation when there is a slope is 0. So we can take differentiation only if dt by dh becomes 0, dt by dh becomes 0. Because see, in the case of this portion for the entire h, for this region, you cannot change time, you cannot do anything because time is constant for this region t1. But yes, of course, here there is a change, here there is a change for that. So dt by dh is equal to 0. Take differentiation. Taking differentiation, you can take 2 by g outside, 2 by g outside, so root 2 by g outside. So you can have here h minus h power minus 1 half plus h power minus 1 half. You can take differentiation for that. This will become root 2 by g. Here become minus 1 half. Right? So it was not minus 1 half, it was plus 1 half. Then it become h minus h, 1 minus 1 half. So become minus 1 half plus h minus 1 half. Like that you can have equal to 0. This term is not required. You can remove this also. So h minus h is inverse. And you can inverse, what inverse? You can just have opposite side. So h minus h is equal to h. Capital H minus small h is equal to h. Right? You can turn this h. So h is equal to 2h. And capital H is equal to small h is equal to h by 2. Do we have small h is equal to h by 2? Oh, equation. We have solution. So this kind of question will be there. A concept based question are definitely waiting for you. Answer is C. Example number 16. A body is projected horizontally. Body is projected horizontally with a speed u from the top A of a plane ABC. So triangle is given here. ABC, an inclined angle theta 30 degrees is given with the horizontal. It strike the point P. Right. So object it is moving here and it strike at the point P, at the strike at the point P. See, you just need to consider this as a y axis, y line, and this is x distance. Forget this triangle, forget this triangle. You just find out x and y. Problem is now simple. Problem looks very simple. If you hide this portion, then problem looks very simple. Let's start. So theta is 30 degree. For this is given initial velocity. We have ux is equal to u cos theta, uy u sin theta. We have that x is equal to ut. We can have t is equal to u x by u and y is equal to 1 of gt square. So we can take y, you can put value of t in this equation. We did this exercise previously also. So y is become gx square divided by 2u square. We got equation for that. We got equation for that. We just need here AP. We need AP. So we know that AP is equal to root x square plus root y square. Also we know that tan theta is equal to y by x, or you can say AD by dp. So y is equal to tan theta. Can we write y is equal to x tan theta? Of course we can. We can. Wow. Y is equal to x tan theta. We already have a value of y is equal to gt square 2u. So x is equal to 2u square tan theta by g. Now we have AP is equal to root x square plus y square. Put the value of x here. Put the value of y here. So x square plus x tan theta square. We can take x outside. So x is equal to 1 plus tan theta square. What is 1 plus tan theta square? Oh, sec square theta, and that becomes sec theta. And put the value of x here. X is equal to 2u square tan theta by g. Put the value of tan 30 and sec 30 and g. G is not required because g is already there. So AP is equal to, resolve this. AP is equal to 4u by 3g. Such an interesting question. So this kind of questions may be there in the examination. Be ready with this. We have one question, again question from JEE 2003. Example number 17. The coordinates of a moving particle at any time t are x is equal to alpha t cube, y is equal to beta t cube, where a and b are constant. Alpha and beta are constant. Okay, alpha and beta are constant. The speed of the particle at a given time t, oh, we need velocity. So we know that x is equal to alpha t cube, y is equal to beta t cube. We need velocity. So we need differentiation along x. So what is differentiation for this? Alpha. So it becomes 3 alpha t square. And what about y? It becomes 3 beta t square. Oh, now we need magnitude. V is equal to root 3 alpha t square power square. We can take this outside, 3 t square. We can take outside. So it becomes 3 t square alpha square beta square. We have this? We have D as a solution. Thank you very much for watching Physics a Doctor.